Alright guys, today we're going to look at solving systems of equations by substitution. Now, what we looked at last time is that if we plotted the graph of two equations and we figured out where they crossed, we could figure out a solution to both equations. Okay, and that's what solving systems of equations is. Finding a solution that works for not just one equation, but both equations. Okay. Before we get into this new method that we're going to try called substitution, let's do some review first. So, plot these two graphs, see where they cross, and see if you can find the solution to both equations. Pause and then come back. Okay, so the first one is actually already in slope-intercept form, 3/2 x plus 1. So we don't need to make a chart for that one. We can just start at a y-intercept of 1 and then go up 3 and over 2. And since I have a slope, I'm just going to make as many points as I can fit on here. Okay, then I'm going to connect them with a line. Now my second one, this one I am going to need to make a table for. Look at that, in green. So second one's going to be in green. Let's see. The first one that comes to my mind is actually -1 and 0. The next one that comes to my mind is 0 and 2. And then I guess the next one that comes to my mind would be 1 and 4. All of those make -2, so now I got to graph all those points. There's -1, 0. There's 0, 2. And there's 1, 4. Okay, I'm probably going to want to make a few extra points, but look, again, once you have 3 points on there, you can actually use the fact that, hey, this line has a slope of 2 over 1, and you can make a bunch more points. And what we find is these lines have very similar slopes, but not quite the same. And they cross right here. They cross at -2, -2. Okay? Alrighty. And again, we know what the limitations are of graphing. It takes a while, and it potentially can be very inaccurate. So we're going to learn one other way. It's called substitution. Here's how it works. You're going to have to recall how we solved literal equations. Okay, so those are the equations where you would solve for x, but there would still be some y's or other variables in the answer. That's what you're going to have to do. You're going to have to solve one equation as a literal equation, and you can solve for either x or y. It doesn't matter. You should pick the one that's easiest to solve for. Then you substitute that value into the other equation, and I'm going to show you what that looks like. Solve the equation, plug in the solution, and solve the other. So let's see what this looks like. First thing you need to do when you're assessing this is when you see these two equations, you need to figure out, okay, which variable looks like it'd be easiest to solve for in which equation. Like you can solve for the x in the first, the x in the second, the y in the first, the y in the second. From my perspective, well, you know what, let's just take a pause for a second and make sure you know which one you think is easiest to solve for. Okay, hopefully you have in your mind which one you think is easiest to solve for. I know which one's easiest to solve for, and it's this one. Okay, and the reason is there's no coefficient out in front of x, so we're not going to have to divide by anything, and that's what tends to cause lots of fractions and stuff like that, which we just don't want. So all we'd have to do to solve for x in this first one is just subtract 2y from both sides. We get x equals 6 minus 2y. Okay? Now, substitute into the other. Remember what an equal sign means. It means that x is the same as 6 minus 2y in that first equation. And here's what we know. When you're solving a system of equations, the x in the first equation is the same value as the x in the second equation, okay? Because we're looking for the place where they have the same x and the same y. So now what we're going to do is we're going to rewrite that second equation. But we're going to take out the x, and we're going to substitute in 6 minus 2y. Okay, so again, all I did is I rewrote that second equation, and I substituted in the value 6 minus 2y, because that's what I found x is equal to in the first equation. Now look what I have. I have one equation and one variable. Okay, very similar to stuff we were solving in like the third unit. Okay, so we need to do some distributive property, but really after this we're just kind of simplifying a lot here. Okay, I'm going to do two things at once because I'm running out of room. I'm going to subtract 18 from both sides and combine my like terms. I get negative 10y equals 10. Divide by negative 10, y equals negative 1. So now I know that y is negative 1. So what I need to do, all I have to do now is plug in that value of y equals negative 1 into any place in here that's got both an x and a y. I think the smartest place to put it, though, is right here. Okay, that's where I would put it, is right there, in for x equals 6 minus 2y. Okay, so I'm going to rewrite x equals 6 minus 2y, except I'm going to put in the negative 1. This turns into x equals 6 plus 2. And I get x equals 8. I should probably check my answer. That would be useful, but if I check it out, it works out well. So like the first one, I'd get 8 plus 2 times negative 1. Yep, that's 6. And in the second one, I get 3 times 8, which is 24, minus 4 times negative 1, that becomes a plus 4. 24 plus 4 is 28. Boom, it works. Okay, so that's the whole process. I think the hardest part is figuring out which variable you're going to solve for. So here's what I want you to do. Do f and g on your own, pause, and then come back. Okay, hopefully you did that. In f, guess what? You don't have to do any solving. This one's already solved for y for you already. So you can now plug that into the second one. And you should always use parentheses when you're plugging in multiple terms for a single term. But in this case, the parentheses don't do anything because, I mean, really, there's just a 1 out there. Distributing a 1 doesn't really do anything. So we really didn't even need to write the parentheses here. Combine like terms and subtract 1 from both sides. We get 5x equals negative 10. Divide by 5, x equals negative 2. Plug that into the first one. And we get y equals negative 3. And again, you should probably check your answers, but they'll work. Last one. Again, I would solve for this y, again, because there's just nothing to get rid of in front of the y, so we're not going to cause any weird fractions. Although, to tell you the truth, the last y would probably have worked out okay as well. Okay, so add 2x to both sides. And we get y equals 2x minus 4. Plug that into the second equation. And we definitely need to use parentheses here. So again, that 3 that was there, that 3's got to stay. Okay, all I'm taking out is the y. Now I've got a lot of simplification to do. Okay, so I get negative 6x plus 6x minus 12 equals negative 12. I'm going to add 12 to both sides and combine my like terms. Negative 6x plus 6x is 0, and I end up getting 0 equals 0. Well, that's weird. You should know what this means already, okay, because we have done this before. It means the exact same thing it meant back in Chapter 3 when we got 0 equals 0. This is an identity. An identity means something that is always true. So the solutions that will work for this one, basically what this means is this. Any solution that works for the first equation will work for the second equation as well. They're two versions of the exact same equation. Okay? So there are an infinite number of solutions to this equation. Anything that works for the first one would work for the second one. They're the same line. Like if you were to graph these, if that were your first line, then that's really hard for me to do. That would be your second line. Okay, they have the exact same solutions. So that could possibly happen too. If for some reason you didn't get 0 equals 0, if you got like 0 equals 5, we would know that that was no solution. And that would mean that it was just two parallel lines, two lines that are never going to cross. They never have the same answer. So that's a possibility with system of equations that you have to watch out for. That's it for this one.